In this video, we're going to talk about the covalent bonds and see what makes them unique, what separates them apart from the ionic bonds, and how to look for the difference between them. So in this video, we're going to be using these vocabulary terms, which is chemical compound, covalent bond, and molecular bond. You might already be familiar with the chemical compound, but we're just going to go a little bit deeper into covalent and molecular bonds. So now, this is the same slide that I had in the ionic compounds, but it's still very important to remember these. So remember that when two or more atoms are joined together, they're held together by a chemical bond. And these chemical bonds are made of valence electrons, and it's really important to know the ratio between elements, how many atoms of each element we have, because in this example here, CO and CO2, they're both compounds made of just carbon and oxygen. They have the same elements, but because they have different number of atoms, that makes them completely different compounds. And so, as we said before, the types of bonds depends on the elements that are in that compound. And for this, we'll be talking about covalent compounds and molecular compounds. And see, these two are examples of those covalent compounds. And I just want to point out right now that I call them covalent compounds, but another way to call them is also molecular compound. So if you look up online, if you're reading a book on this and you see molecular compounds instead of covalent, it's still exactly the same thing. It's just a different name for it. All right, so just keep that in mind. But for the rest of this video, I'll be calling it covalent compounds only, and I'm going to ignore the molecular compounds out of it. In the covalent compounds, to make a covalent bond, we need to have two nonmetal elements. So if you take it back to the periodic table, the nonmetals are those that are here on the right side of the periodic table, plus hydrogen. Remember that hydrogen is the exception to the metals. Even though it's on the left side, it's still considered a nonmetal. And so the most common elements we'll be seeing for our covalent compounds are things like carbon, nitrogen, oxygen, phosphorus, and sulfur, hydrogen, of course, and then the family of the halogens, which is the fluorine, chlorine, bromine, and iodine. These are the most common ones we'll be seeing for covalent compounds. But remember that there's still a few more nonmetal elements that we might see in a covalent compound. All right, and now the covalent bond is a very special type of bond because it involves the sharing of electrons between atoms. So what does it mean to share an electron? So if we're looking over at this graphic on the bottom right, it's just a molecule of CH4, and notice that it's color-coded too. So these electrons in blue, those are the ones that come from carbon. So if you go through and you count them, you see 1, 2, 3, and 4. These are the valence electrons of carbon. So carbon can bring in 4 valence electrons, which is like 4 single valence electrons. That means that it can make 4 bonds. Each of these hydrogens, they bring in 1 red electron with them. And so sharing these 2 electrons, they go to both the carbon and the hydrogen, and this is what's holding their atoms together. Now, the reason that this happens and they don't transfer over like they do in ionic compounds is because we have very small differences in the electronegativity of these elements. So if we take it back to this electronegativity chart, remember that for covalent compounds, we need at least 2 nonmetal elements. They're all over on the right side, so you can see that the heights of their graphs on here, they're very much closer together than they are if you compare it to the metals. So because of that, it's a constant tug of war where no side is winning on this. So in this one, carbon has brings its electrons, but it can't lose them to hydrogen. Hydrogen isn't strong enough to pull them away. But same thing for carbon, it's not strong enough to pull away the electrons from hydrogen. And so again, it's this tug of war, it's the constant sharing between the electrons. And so the electrons can be part of the carbon ring, or they can also be part of the hydrogen ring, and it actually happens for both of them at the same time. Now let's look at the bonds a little more closely. So as we said before, is that for the covalent compounds, we are sharing 2 electrons between atoms. So bringing this back, let's actually zoom in and talk about it in a little bit more detail. So we have this way of writing out our compounds, showing their structure and showing where each electron came from and where they're being shared. So in this case, this carbon is sharing 2 electrons between this hydrogen, 2 electrons between the top hydrogen, and then the same for the other hydrogens. Now, it takes a little bit of effort to write a structure like this, just keeping track of all your electrons. So there's actually an easier way to write these out. So let's go ahead and look at that. So to do that, I need to take my atoms and copy them over on the right side. I want to keep the same structure on this, but I'm just going to connect them a little bit differently. Where in this case, I'm going to take the carbon and the hydrogen, and I'm going to connect them with a line. It's called the bond line that shows how my atoms are connecting to each other. And what's important to realize about these bond lines is that it actually represents the two electrons that we had in this Lewis dot diagram before. So if we fill in the rest of our bonds, again, anywhere they have two electrons between two atoms, you replace it with a bond line in this way. And when you do this, these are two very similar structures that are actually the same compound. They still show the same information, just a little bit differently, because these lines contain two electrons. It's the same as when we were drawing them with individual dots. So I think this way is a lot easier to keep track of your compounds. It's a little bit faster to write them this way, and it's really great to see how they're oriented and what their spatial relations are to each other for the atoms. Three, two. And let's talk about some more details about these bonds that we can have. So let's break it down and make it a little bit more simple. Let's say that we were looking at this structure of just two hydrogen atoms being bonded together. They're sharing these two electrons, right? So the next way we can write this is, instead of the two electrons, we can draw a line connecting the two atoms. And again, this is still the same structure, same information, just drawn a little bit differently. But what I want to point out at this point is that some atoms can make more than one bond. So let's start with just one. So when you do this, we have just the single bonds of hydrogen. But as I just said, we can make more than one bond with some atoms. So let's look at this example where we have oxygen with two lines drawn between the oxygen atoms. So what's actually happening here is that this is a double bond for these oxygens, and what's happening here is that the electrons that are being shown, really, it's two pairs of electrons being shared between these oxygen, not just one pair like it was over here with the hydrogen. So remember that this line between the hydrogen represents two electrons, but two lines, that means that there are four electrons between them. And we can go one further. We can actually have three lines between atoms, and this will be what we call a triple bond, because there's three bonds connecting these two atoms. And same thing, each line represents two electrons. So if you're to write the Lewis dot diagram, you would show 6 electrons total between the nitrogens. It's 3 pairs of 2. Let's take a short moment to just review everything we've covered so far, both for covalent and ionic compounds. So let's go ahead and draw a T-chart so we can easily compare the two and see what their differences are. So for the covalent compounds, remember that we use these structures where we are sharing electrons between elements. Now, which elements in particular? Remember that it has to be at least 2 nonmetals. You can't have any metals mixed in with this to make a covalent compound. Remember that the electrons are shared between atoms. So remember that carbon here brought 1 electron, hydrogen brought another electron, and those 2 electrons are what's holding the 2 atoms together. And we call those pairs of electrons, we call them bonds, and they are the connections between our atoms. Now, if we compare that over to our ionic compounds, remember these happen between metal and non-metal atoms. You need one of each to make an ionic compound, and these are special because the electrons are being transferred. They're not shared like they are in the covalent compounds. Instead, the non-metal is so electronegatively strong that it pulls the electrons away from the metal and completely takes them away. Remember, as a rule of thumb, is that metals always lose electrons, and non-metals will take those electrons away from the metals. All right, when you do that, we get an imbalance of electrons, and so this throws off our electrical charges. So where we have a neutral atom, when we have the same number of protons and electrons, when we mess with that, if we lose electrons, we get a positive ion. We call that the cation, And if we gain more electrons, we're gaining more negative charge, and we get an anion. And now, having that difference in charge between ions, you want to match them in opposite signs, and that's called the electrostatic force, and it's what's holding our ions together. All right, so that's going to do it for the ionic compounds. This is just an overview of the basic principles that we're looking at. And so in the next section, we're going to be looking at metallic bonds, when we can have two nonmetal atoms and see what happens between them.